Hi everyone. In today's challenge, we are going to solve this problem. The problem name is minimum ASCII delete sum for two string, and the problem number is 712. Alright, guys. So first of all, what we are going to do? We are going to clearly understand the problem statement. After understanding the problem statement, then only we will move to the logic part. And in the logic part, we are going to see how we can solve this problem. What is the logic we are going to use to solve this problem? So after understanding the logic part, then only we will move to the implementation part. And in the implementation part, we are going to implement our logic in Python, C++, Java, and JavaScript programming language. Fine guys, and guys, if you want to have a look on the solution which I'm going to write for this Python, C++, Java and JavaScript programming language, I will share the link in the description. You can go through that particular link and you can find all the solution, right? Fine guys, now let's see what this problem says. So let's understand the problem statement. Problem says given two string s1 and s2, return the lowest ASCII sum of deleted character to make two string equal. So guys, we are given first of all two string, right? S1 and s2. Fine, and what we need to do? We need to return the lowest ASCII sum of deleted character to make two string equal. So definitely we have to first of all make the string equal as such that we have to make these two string equal such that the sum of ASCII character should be the lowest, right? Should be the minimum, right? So let's understand this with example, then you will have a better understanding what we need to do, right? So in the first example, you can see we have C, right? So let me write here S1 is C and S2 is E. You can see both are not equal, right? Both are different. C and E are different. But first of all, we have to make them equal. So what I can do, I can say right C and E. So if we want to make this both string equal, so what we can do, we can delete S from here and we can delete T from here. So you can see both will have now EA, right? These are nothing but equal string now. So how we have deleted two characters, so we have to add their ASCII value, right? So ASCII value of S ASCII value was nothing but 115 and T ASCII value of T is nothing but 116. So we have to add them, so we'll get nothing but 231. So I hope it makes sense, right? So we are deleting a two character to make S1 and S2 equal, and the cost means nothing but we can say ASCII value of this both character, and after ASCII value of this both character was 115 and 116. So after adding these both character ASCII value, we are getting a 231, which is we need to return, right? So we can say this is the lowest ASCII sum of deleted character to make S1 and S2 equal, right? I hope it makes sense. So let's see the second example, then you will have better understanding what we actually need to do, right? So in the second example, we have nothing but first S1 is nothing but deleted. So let me write here the S1 is nothing but delete and S2 is nothing but lead, right? So this is the second example. Now what we need to do here, we need to make first of all S1 and S2 equal, right? Because you can see clearly they are not equal. So what we can do to make it equal? So first of all, we need to delete some character, right? And remember guys, we can only delete the character. We cannot insert the character, we can just delete the character. And we have to add the ASCII value if we are deleting a character from S1 or S2, right? So there are many ways to make this S1 and S2 equal. The first way is nothing but you can make it lead, not lead, I would say Lee, right? You can make it Lee and here also Lee. So this is the first way to make Lee. And how you will get Lee here? So you can see you can delete D, E and T. You will get Lee, L double E, right? You can delete D, E, T from here and you can delete here only T. Right? You will get Lee. And you can see in the explanation part also they are saying the same thing. You can make Lee here as well, right? The second character which you can make is nothing but double ET, right? So you can see double ET. So how you can make double ET? So for making a double ET, you can say I can delete this one. For making double ET, I can say I can delete L, I can delete D, and I can ET. D and E I need to delete from S1, and here I need to delete L, so I will get double E T. Right. The third way of making S1 and S2 equal is nothing but you can say simply we can make it is LET, right? So LET, we can make it LET, and for making a LET, what I can say I need to delete D double E, right? And I need to delete here E only, right? So I can make it LET, right? So you can see guys, there are three ways. The first way is nothing but this one. We can make LE on the S1 and S2. We can make EET on the S1 and S2. We can make LET on the S1 and S2, right? But for all these three equal string, we need to delete a character, right? So we need to delete. We need to take one of the string, right? We can either take this one, but which one that decided by the lowest ASCII sum value, right? So if I use this particular string, if I make this S1 and S2 LEE, right? So what I need to do? I need to delete some character, right? So which is nothing but DE T, right? I need to delete this character from S1. But you can see the cost of deleting a T would be higher, and cost of deleting a T will be high, right? And if I do this way, so I will get a higher cost, which is nothing but they have already mentioned. You will get a 433 cost. But if you make EET, then you will get a 471 cost. And if you make LET, then you will get only what? Only we can say 403 cost. So I hope you are getting this part right. So we can have a lot of possibilities to make S1 and S2 equal, but we need to pick that possibility which are giving us a less cost. Less cost means nothing but less ASCII sum of deleted character. So here at the last we just need to delete few character, that is nothing but D, E, and we can say E, right? DEE. We need to delete DEE, And you can see here we have EED, which will have some ASCII value which is less than the T value, right? We can say T and L value, right? Because the bigger term, bigger character, we are already taking in our string equal as L and T, which was making a ASCII value bigger, right? So here we are deleting only DE, which will cause a less, and here also we are deleting only E. So we are getting 403 only. So we are going to return 403 because by making S1 and S2 equal to let, we need to delete the character which is having a low ASCII value, which result us nothing but lowest ASCII sum. So we are returning a 403, right? So that means nothing but we just need to return 403, that is nothing but the lowest ASCII sum value. So that is possible by having a this string equal. I hope it makes sense, right? Simple thing, guys. Making a S1 and S2 equal, there could be many possibilities, right? And you need to pick that possibilities which are giving us a less ASCII value, right? We have already seen this second example. Now let's move to the logic part, how we can do this particular one. So in the logic, guys, we are going to spend much time here, and believe me, guys, you will find this video very long, but this video is going to be really helpful for you in the future problem as well, because the logic is going to be really easy and it can use in future problem as well, right? So what I'm going to do here, guys, in the logic part, first of all, we are going to see the recursion. And see, guys, recursion, if you don't know recursion, then you can't come up with a DP approach. For DP, recursion is a must, right? So what I'm going to do, I'm going to say recursion. How we can solve? First of all, let's see recursion. Then we will going to move to the bottom up, right? First of all, we are seeing top down. Then we will move to the bottom up. So how we can do it with recursion? So recursion, we are going to say we are going to use the SE only, right? C and E. We have taking a first example. We have C and E. So we are not going to make. Just try to find out the relation which are going to change every time. Think about this. So if you're getting this, we are going to say I and J. I is nothing but the index of S1 and J is nothing but index of S2. So initially both will be 0, 0. I hope this making a sense, right? So we can say initially we are standing at a 0, 0. So if I write here, let me change something. So S1 was nothing but we can say C and S2 was E, right? So these are two characters, S1 and S2. So what I am doing here, that I am starting at a 0 position, right? So I'm going to say I'm at 0 index, 0 index, right? So I'm starting at 0 index. Now there the possibilities comes. Now guys, see, from 0, 0 means starting decision. If character are same, then we can move ahead. But if character are different, then we have to think about something, right? So let me just show you a later diagram. See, guys, on this possible, we can have two choice, right? If equal, if not equal. So here you can see S and E are not equal, right? So what we can do, we have two choice. If they are not equal, then also we have two choice. That is nothing but we can say. If they are not equal, then what we are going to do, either we can delete a character from S1 or we can delete a character from S2. So I can move ahead 1, 0 or 0, 1. This what it is say 1, 0 is nothing but we can say I have deleted from S1. So S1 will be here now, right? And this S2 will be remain here only because it is 0. Or what I can do, I can say I can delete a character from S2. So in the second possibility 0, 1 indicate that S1 is here only. You can see my cursor and S2 will be here. You are getting this part. But if the string is equal, then we just simply move to ahead, right? 1, 1, right? But here you can see string is not equal, so we are not moving ahead. We will not say we'll come here part, right? Okay, we got 1, 0 and 0, 1, right? That means nothing but I have deleted either the character from S1 or to S2. But we have deleted it. We need to add the ASCII value as well, right? You can see we have to add some the deleted character. So if I am deleting a first character, you can see I'm deleting a from S1. I'm moving ahead, right? So I'm deleting a from S1. So I have to add the ASCII value of S. S ASCII value was what? 115. So I can say this network 115. So let me write from here 115. And if I'm deleting from we can say S2, then I have to add the ASCII value of E, which is nothing but we can say what could be 101E, right? 101. Fine, it makes sense, right? So it makes sense. Now we are start from we will do the recursive part from this particular two position. So from 1, 0. So you can see from 1, 0, S of 1 is nothing but E, S of 2 is nothing but E, S of 2 of 0, right? Because you can see it is lying here, it is lying here, right? So you can see both the string here equal, right? So if a string is equal, then we don't need to go anywhere. We can say simply if it is equal, so we'll move 2, 1. We're gonna move ahead 1, 1, 1 by one pointer here, by one pointer here, and by one pointer here. Fine. So here you can see we got now 2 and 1, right? It makes sense, right? So what is opening here? I don't want to type here, right? Fine. So 2, 1 is there. Now we have to again match is S of S1 of 2 and S2 of 1 is same or not. You can say S2 of 1, S1 of 2 is nothing but A, S2 of 1 is A. Both are same, right? If both are same, so we are going to say move ahead. So increase 1 by 1, increase 3, 2. Fine. You can see it's let me write here. It's now here. It's out of bound, and it's at 2, right? So if it is now the main condition comes here, also one more condition comes. You can see we have seen the two conditions. If string is equal, cool, you can increase by one index for both S1 and S2. But if string is not equal, you can either delete S from S1 and increase that index, or either delete from S2 and increase that index. But if you find some a case like this, you can see one string is out of bound, then you have to add the ASCII character of the second string, whatever the character left from the second string. And you can see here S1 is out of bound, but S2 has a one character T. So I'm going to add the ASCII value here, and I'm going to return with that one particular. So it's nothing but 115 was going from here. So let me change the color. So I know it's hard to understand, but try to understand from here, right? It's an easy one. So 115 was going here till. So what I can say 3, 2, right? So 3, 2 is nothing but we can say 3, 2. It is out of bound, so I'm going to add the ASCII character of 2, and that is nothing but we can say ASCII character of T is nothing but 116. So I'm going to say 116. So it's going to return from here. So 115 plus 116 is going to be here. So 116 is coming from here. 116 is coming from here. So it's going to return nothing but answer 231. I hope it makes sense. So it will return answer 231, because now we are returning 231. Because if I go this case, so I will get definitely more than that. So you can see 231 was here, and it will be definitely more than 231. So we are going to take a minimum 231 with our answer. So it is a recursion tree. Just I want to make you clear that how the recursion tree is going to work. First of all, we have two choice: equal or not equal. If it is not equal, then we can delete either from S1 or S2. If I'm deleting either from S1 or S2, then I have to add their ASCII character as well. And if I end up with the one string, if I end up with a case where S1 is empty, S2 is have some character, so I have to add the all the ASCII value of all the character which is left from S2, right? If I end up with a case where S2 is empty, S1 is have some character, so I have to add all the ASCII value of the character which is present in S1 and I have to return that part. Fine. So we have seen the recursion part, right? Now let's move to the tabulation part. And see guys, I'm going to implement this in Python only. Why? Because it is a recursion one. So in Python, we have to memorize it, right? Because it is a recursion, it will not work if we don't memorize it. So we have to memorize it. And in Python, we can use a cache, right? But you can use in C++, Java, JavaScript as well. But I'm going to go with the DP or tabulation approach. Why? Let me show you here. So the second approach which we are going to use is tabulation approach. So this will give a TLE, but it will pass the all the rest case if you are going to use a memorization, right? So we are going to see with the Python how we can do that part. And in the tabulation which we are going to use for C++, Java, and JavaScript, let's see how we can do with the tabulation. So for tabulation, you need to know the recursion part. So that's why we have seen first of all recursion, right? For tabulation, you must understand the recursion. So how we can make a tabulation from this particular case? Let's see that part. So guys, we are going to take again SE and EAT, the same example. So what I can do, I can make a tabulation, means I can make an array, I can make a matrix. So for that, I can say this is 3 length, right? This is also 3 length by coincidence, but it may not be in future, right? You can see S1 dot length is not equal to S2 dot length. It has not cleared that as right. So S2 length could be greater or smaller, right? So what I'm going to say, I'm going to create a matrix. So I can say, let's take a table here, right? So we have a table feature here. So why not take it? So this is 4, this is 4, right? So this is a 4, 4. So I have taken this table feature and I'm going to write here. Okay, this is a simple thing, right? So this is nothing but I have writing a SE here and EAT here. And this is 0 index, 0 index. We are not writing here anything. This means nothing but empty string. This is also empty string, right? Now let's write a index as well. So draw, let's take a green pencil. This is index 0, this index 1, this index 2, right? So we can say nothing but indexes is going to be look like this 0, 1, 2, 0, 1, 2, 3, right? So this is index. Now we have written a, you can focus over guys. This is nothing but we have matrix from SE and EAT, right? So S1 we have right in the row side and S2, this was S1, right? And this was S2. So S2 have we are right in the column wise, right? Fine. Now we are gonna default, we can say if both string are empty, so that means they are equal, right? Focus here guys. If both string are empty, that means they are equal. So we can write here 0. Does that make sense, right? So we can say if both are string empty, we don't need to delete any character. We can return 0, right? But focus here guys. Now we have to fill this first row and first column. How we can fill that row and column? So for filling S1 and S2, for filling a first row and first column, we can say, assuming guys, what this particular cell represents. This particular cell represents nothing but we can say, we don't S2 we have nothing, S1 we have S only one character S. So we have to make it equal, we have to delete S1, S only, this character. Right, we have to delete this S character. So for deleting this S character, we have to add the ASCII value, and this ASCII value was nothing but 115. Same goes for this. For this cell, what this cell represent? So tell me this, what this cell represent? This cell represent which nothing but E, right? So we can say S1 we have SC, but S2 is still empty. So we have to add this, we have to delete this 2 character. Right? I hope it making a sense. So we are going to delete this 2 character, which will get nothing but 216. Right? So we are going to get this 216. Then we will go to for A as well. So I have written somewhere. So let me just see from there. So it is nothing but 313, and this is nothing but 101. This is nothing but 198, and this is nothing but 314. Simple guys. We have fill first row and first column, which we are going to fill by default. Why? Because this complete row tells us that S1 is empty. This first row tells us that S1 is empty, but S2 has some character. So we have to delete all these character. And same goes for this row, this column. So this column tells us that S1 is have some character, but S2 is empty. So we have to make it equal. So we have to delete all the S1 character. So for this cell, we have to delete all these three character to make it equal. For this cell, we have to delete all these character to make it equal. So we have filled our we have initialized our matrix. Now we are going to fill this all these cell values, right? So tell me what this cell value represent. This is, let's say the matrix name is DP. So I'm going to say DP of 2. Okay, DP of 2 and DP of 2, right? So DP of 2 and 2 represent what? What represent? It represent that S1 we have SE and S2 we have EA. S1 we have SE character, S2 we have EA character, right? So we're gonna say this cell represent how many, what is the lowest ASCII value, lowest ASCII sum of deleted character to make it SC and EA equal, right? It makes sense, right? So now guys, let's fill little matrix. So what I'm gonna say, I'm gonna say if character is not same, so I'm gonna first of all with this one, right? So I'm just gonna fill 2 or 3 value to make it equal, to make it visible to you. So what I'm gonna say I'm first of all DP of 1, 1, right? What I'm going to say if they are character equal or not. S of this S and E are equal. No, these are not equal. If these are not equal, so what we are going to do in recursion? What we were doing? We were saying we are either removing the character from S1 or either we are removing from S2, right? You can see if they are not equal, so we are either moving one ahead of S1 or we are moving one ahead of S2, right? Same thing we are going to do here. So if character is not equal, so either we can delete E, either we can delete S, making a sense, right? So if I am deleting a E, so what I need to do? I am doing a one relation here, guys. If S1 is not equal to S2, right? If S1 is not equal to S2, so what we can do? We can say we can either delete E or we can either delete S now here. In this case, right? We can delete either from I character, from column, or we can either delete from row, right? So what I can do if I'm deleting a E, right? If I'm deleting a E, so what I need to take, if I'm deleting a E, so I need to take DP of I comma J is going to be equal to what? DP of I and J minus 1. Because I am deleting a E, which is nothing but a column part. So if I'm deleting a this one, if I'm deleting a this E, so I have to take this particular value, right? This particular value is nothing but without E, right? This particular cell represent that without E, right? And after that, I have to add the which character which I have deleted. I'm going to say which character we have deleted. We have deleted a E character. So ASCII value of that E. ASCII value of E. Another case is could be either I can do, either I can, let me undo this part, not this part. Let me move this part. So this was 115. So either I can delete S, not E. So if I'm deleting S, so I can say DP of I minus 1 and J. So I'm going to take this value. I minus 1 means this one value, 101, plus ASCII value of what? Which character I have deleted? S. So ASCII value of S. I hope it making a sense. So we will get nothing but 216 here, right? So I hope it makes sense. Either I can, so we have to take minimum of this now. Minimum of this, the first of, second of. So we have to take minimum of these. I hope it makes sense. So now let's move to the next ahead. So we are going to fill like this as well, this as well. Now let's see this part, right? So DP of 2 and 1, 2 and 1. So here we get same character, E and E. So here we get same character. So what I'm going to do, I'm going to say if character is same, so don't need to delete anything. You just take a previous one. DP of I minus 1, J minus 1 means this one set. So this directly will come here, 115 will come here. I bet it makes sense. Same if we'll do this one, so you can see we are getting the same character A and A. So we'll write directly 115 here. At the end, but we need to return this part, right? So here you can see A and T are not same. A and T are not same. So either what I do, I can delete a T or I can delete a A. So if I am going to delete a T, I am going to write this particular value 115 plus ASCII value of T, which is nothing but 116. So we are going to get 231. And you can see this cell is going to have 231. And at the end, what we need to return? We need to return this cell only. The last bottom right cell, right? Bottom right cell. So we have to return this particular cell only. And we will return 231 answer. So I hope guys you have seen the relation. If both characters are not same, so I'm going to either delete a J minus 1 or I'm going to delete a I minus 1. I'm going to take a minimum of this. Or if they are same, so I'm just going to write here. You can see here, just I have to write the previous, this one value means I minus 1 and J minus 1 value. Simple thing, right? So we have seen the tabulation part and the recursion part as well. Now let's move to the implementation part and let's see how we can implement this part, right? So how we can implement this part, let's move to this. So guys, first of all, note this one, guys. I'm going to say, first of all, I'm with the Python. So what I'm going to do, I'm going to say, for Python, I'm going to say, let's make first of all recursion. For Python, we are going to do the recursion part. So I'm going to say how we can do recursion. I'm going to say define solve. I'm going to make this array solve, not array function, which is going to be called recursively. I'm going to say ing, right? Because ing is going to be, we have seen in this part, not in this part, you can see in recursion part, we have seen these are going to be change 0, 0, right? Fine. So what I'm going to say, I'm going to say if I is, first of all, let's calculate the length, right? So I'm going to say n is equal to length of s1 and m is equal to, let me write m is equal to, let me write m is equal to length of s2, right? Fine. So we have got the length of s1 and s2. I'm going to say if I is equal to n and j is also equal to m, means both are end of the string. So we are going to return nothing but 0 only, right? We have seen this base condition. But if I is equal to n, so what we are going to do? If I is equal to n, so we are going to take all the character which are left from s2, and we are going to return the ASCII value there, right? So we can say get ASCII sum, and we are going to pass our s2, right? And we are going to pass our s2, and which we are going to pass? We are going to pass this index j, and we are going to pass the length of this m. Fine. And if j is equal to m, means j got empty earlier, so we have to take all the character from s1, return get ASCII sum s1 I and n, right? Fine. Now we are here. Now we know that none of the string got empty, and now we have to check whether they are equal or not. If s1 of I is equal to s2 of j, right? If both are same, if s1 of I is equal to s2 of j, so what we can do? We can say simply move index by one both for both of the strings. So we can say return sol I plus 1 and j plus 1. Simple thing. It makes sense, right? But if they are not equal, then we can say either move one ahead of s1, either delete one s1 character, either delete one character from s1 or one character from s2. So we can say return. We have to so we can take minimum. We have to take from minimum. So we can solve. We are going to take delete first from s1, and j will remain same. So if you're deleting, you have to add their ASCII value. So we can say odd of s1 of I, right? Or you are going to say sol I comma j plus 1. You're deleting from s2, so you're going to add their ASCII value, ORD of s2 of j. Fine. After that, you can simply say return, not return. We are going to call this function sol. We are going to be 0 comma 0, starting from 0 comma 0, right? But see guys, we have used one function get ASCII sum. We haven't defined that, so let's define that function as well. So I'm going to say get ASCII sum, right? And this sum is going to be take one string, starting index, ending index, right? And we're going to say, okay, we can do in just one line, right? We can say simply sum. Here we can say ordinary of I, or we can say character c, and we can say for c in s of start and end. It make it easy, right? So we just use a list slicing, right? Fine. Now we are going to say, let's see whether it's working fine or not, and it will definitely going to work, I believe, guys, because we haven't done any mistake. Let's see whether we have done or not. So you can see, guys, we haven't done any mistake and pass all the test case. Means both only two test cases are here, right? Simply think, guys, we have just taken the rest of the string, right? ASCII value of rest of the string in this function, and we have just done in one line by using a list slicing, right? Let's try to submit this code. So I hope it should work, right? So it's just a simple recursion, guys, and it will give a TLE. Definitely, it will give a TLE because we haven't memoized it. So, but let's see how we can get a TLE. First of all, we are seeing a TLE. It's gonna give a TLE. Let's see. You can see, guys, we got a time limit exceeded, right? Fine, and it could pass only 27 test cases. Now, how we can solve this? So we have to just use a memoization, and in Python we can use a simply cache decorator, right? But in C++, Java, and JavaScript, you have to make a one matrix, or we can say map, hash map, and you have to keep inserting this I, j as a key, right? If you are finding this key again, you have to return that particular value. Now let's try to submit this code, and it definitely gonna pass all the test case, right? It will not give a TLE because we are now using a memoization. You can see, guys, it successfully got submitted. Now we got one more award. Fine. Now let's move to the next programming language, nothing but C++. Now here we are going to start our tabulation approach, right? So for tabulation approach, we need n, which is nothing but s1 dot length, our m s2 dot length. Fine. Now once this is done, then what we are going to do? We are going to say fine, we got n and m. Now we are going to say, okay, let's make an array, or we can say vector of int, and we are going to say the row, means we can say the number of rows is going to be dependent on the s1. So we are going to say n plus 1, and the number of on each row we are going to say vector. On each row we will have vector, and that size is going to be n plus 1, means column, and default value we are going to say 0. Fine. See, guys, why I have used n plus 1, n plus 1? So if you will focus here, so you can see, guys, we are making a matrix with one more size because we are making one for empty string as well, right? So same thing we are doing here. Fine. After that, what we can say? We can say for int I is equal, not int row is equal to 1, row less than equal to n, and row plus plus. It makes sense, right? So what I'm doing here, guys, I'm gonna start filling our first row, not first row, first column, right? So I'm gonna say I'm gonna fill this initial row, column, right? 0 column, right? So for that, what I'm gonna say? I'm gonna say our dp of, we can say, row, this gonna be, and column remains same 0. dp of row and column remains same 0 is gonna be equal to what? Is gonna be equal to dp of row minus 1 or 0 plus ASCII value of this, we can say s of row minus 1. So ASCII value, how we can get? We can get int, and here we can say s1 of row minus 1. So this is how I can fill our first row. The same I'm going to do for int column is going to be nothing but 1, column less than equal to m, and column plus equal to 1, right? So here I can see dp of row remains same, column will keep vary, and as we are filling out in one row, so first row, so we can say dp of 0, column minus 1, and we can say plus int ask a value of s2 of column minus 1. So this is nothing but how we have filled our first row. So we have filled first row and first column. Now what we are going to do, we are going to use our tabulation approach. For int I is equal to 1, I less than n plus I less than not I less than equal to n, and I plus plus, and same thing we are going to say here for int j is equal to, we can say 1, j less than equal to m, j plus plus. Right. So what we are going to do here, we are going to say if our s of I, if s1 of, not capital S, if s1 of I is equal to s2 of j, means their characteristic string are equal, right? Both string are equal. So we need to just take a value dp of I and j is going to be nothing but the previous one, dp of I minus 1 and j minus 1, right? But if they are not equal, then we have to delete either from s1 or s2, right? So we can say if they are not equals, then dp of I comma j is going to be what? First of all, let me write a minimum, and here first of all we are going to delete from s1. So we can say take the value of dp of I of j minus 1 plus, we are deleting not s1 s2, right? So we are deleting e here, as s and e are not equal, so we are deleting e. So we are saying that dp of I j minus 1 plus, from s2 what you are going to do, you are going to say you have to take ask value, right? From s2 you have to take j minus 1, fine, and comma we can say solve, not solve, we can say dp of here I minus 1 and j. Here I am deleting from our row, right? E, I am deleting from s1, which is nothing but s. So I have to take this cell 101 and I have to add the ask value of s. So I'm going to say plus ask value of int s1 of, we can say I minus 1, fine. After that what we can say, once this is done, we are going to come out from this for loop, we are going to simply return dp of n and m, and this is a simple one, right? And it's easy problem. Let's see whether it's working fine or not. So I believe I haven't done any mistake, but I have done. So what is this mistake? It's saying use of undeclared I never dp. All right, so guys, it's my mistake, I haven't used a dp here. Fine. Now let's see whether it's working fine or not. So I hope guys it should work, right? So it's taking time, but all the rest is false. Why 212 to 103? So do we have something wrong here? Just think about this, guys. We have done something wrong or not? So what I'm saying here, okay. So we are deleting from I minus 1 and we are saying that s1 of I minus 1, right? It's fine because we are deleting from row, right? So we are taking I minus 1, and here also I am saying that dp of I j minus 1, so s2 of j minus 1. It's fine, right? So start from here. M2 is ending by s2 length, and we have seen this is going to be row, this is going to be column, right? On each column we are going to m plus 1, so we are going to say row is less than equal to n, and row plus plus column is going to be less than equal to m, and we can say column plus plus, so we can say 0 of row column. So as column is getting increased, so row is going to remain same, and it's fine, and s2 is column minus 1, right? So it makes sense, right? So it's working fine, and here we can say we have done something wrong over here only. So s1 of, here is the mistake, right? S of I minus 1. Fine, now let's see whether it's working fine or not. So hopefully we found a mistake. So we're seeing nothing but s of s, because this we are starting from 1 indexes, right? So we are not starting from 0 indexes, because as we have make a matrix one length, so we are going to say s of I minus 1 will tell us the 0 index, and s2 of j minus will tell us the 0 index. Now let's try to summarize this code, and I believe guys it will not fail, right? So let's see. You can see guys it successfully got submitted. Now let's move to the next programming language, which is nothing but Java. Fine. So here we are going to say first of all calculate the length, right? So int n is going to be nothing but s1 dot length, and we can say m is going to be nothing but s2 dot length, right here, length, right? Fine. So once we got a length, we are going to make our array. So we can say int, so we can say 2D array, so it's going to be named tp, which is going to be new int n plus 1 m plus 1. Fine. Now we are going to say fill our first row and first column. So first of all we are going to fill first column. So for filling a column, row will remain same. No, for filling a first column, row will change. So we can say row start going up from 1, and row we can say less than equal to n, and row plus plus, right? Fine. So after filling a first row, how we can first column, how we can fill? We can say dp of 0, row will change, right? So dp of row and column will remain same 0, and we can say it's going to be equal to dp of row minus 1 and 0 plus, we can say add the ASCII value of this particular character. So we can say how we can add ASCII value. We can say ASCII value is nothing but, we can write int, and here we can say s1 dot char add, and we can find here what is net, that is nothing but I minus 1, I note row minus 1. So this is how we can fill a first column. So we have filled a first column, so where row was changing, right? And for filling a first row, column will change. So we can say column is going to be nothing but equal to 1, and column will say less than equal to m, and column plus plus. So right, and we can say dp of 0, here we can say column is going to be equal to dp of 0 column minus 1 plus, we can say add the ASCII value. So int s2 dot char add, column minus 1. So this is how we have filled first row where column was changing. Now once we have filled first row and first column, now we are going to use some we can say our tabulation approach. For int I is equal to 1, I less than equal to n, and I plus plus. Same goes for here. For int j is equal to 1, j less than equal to m, j plus plus. And here we can say if our s1 dot char at I minus 1 is equal to s2 of s2 dot char at j minus 1. So if it is the same thing, then what we can say? We can say take the value dp of I comma j value is nothing but equal to dp of I minus 1 and j minus 1. Take the diagonal value, right? Simple thing. But if it's not equal, that means we need to delete some character. So we can say else. So we are going to delete some character which is nothing but dp of I of j is going to be nothing but what? So either you can delete as character from the column. So let me show you how. We can say math dot main. So here we can say dp of I comma j minus 1. So I have deleted from the column, right? So I'm going to take that particular value, and after that I have to take the ASCII value of that particular character. So I'm going to say ASCII value is going to be nothing int s2, right? s2 dot char at. So because on column we are having s2, right? s2 dot char at j minus 1. Or what you can do, you can delete a character from the row, right? Means you can delete a character from the row. So we can say dp of I minus 1 and j plus int s1 dot char at I minus 1. Fine. After that, once this for loop over, so what you gonna do? You can say return. We can say return dpo and nm. And I don't want to see the error in Java. Let's see. It should pass. Let's see. You can see, guys, it's taking a time. You can see, but it could pass, right? So it passed all the rest case. So let's try to submit this code. Hopefully, we did not get any error in Java. But yeah, I really have fear with Java and JavaScript. You can see, guys, it successfully passed. Now let's move to the next programming language, nothing but JavaScript. And this is the I really have a fear with this. Now what we are going to do, we are going to say let n is nothing but s1 dot length, and we can say m is nothing but s2 dot length. So we have taken length of s1 and s2. Fine. Now what we are going to do, we are going to create first of all array, right? dp array. So once dp is nothing but initially empty. So for let I is equal to 0, I less than equal to n, and I plus plus, and we can say dp dot push new array, and here we can say array of how much size, m plus 1 size, right? And we can say after that you have to fill also that with 0 value. So this is how we can do that part, right? Fine. Once this is done, we have created an array. Now we are going to fill initialize with first row and first column. So for first of all, we are going to initialize first column. So for initializing of first column, our row will change. So row will initially equal to 1, and row less than we can say equal to n, and row plus plus. So dp of row will change, right? So row, and here we can say 0. It is a first column. So we are changing in the first column. So first column will equal to row minus 1 of 0 plus ASCII value. How we can get ASCII value here? In JavaScript, I think we can use a char code add, right? So what I'm going to say s1 dot char code. I'm not sure, but yeah, char code add, and here we can pass what? We can pass our row minus 1. Same we are going to do for initializing our first row, where column be changed. Column is equal to 1, column less than equal to m, and column less equal, right? Here we can say dp of 0, and here we can say column. So what it will equal to? It will say dp of column. No, column will change, so we'll say 0 and column minus 1, right? Plus s2 dot char at char code add, and here we can pass column minus 1. Fine. So we have initialized first row and first column. Now let's use the tabulation approach. For let I is equal to 1, I less than equal to n, and I plus plus. Same thing we are going to do here. For let j is equal to 1, j less than equal to m, j plus plus, right? And here we can simply say if our dp of dp s1 dot char at I minus 1 is equal to s2 dot char at I minus 1, means character are same, right? If character are same, then what you are going to do? If character are same, so you can say we don't need to delete any character. We can take just a diagonal value, right? So we can say dp of I and j is nothing but simply equal to dp of I minus 1 and j minus 1. Fine. But if it is not the same case, right? So then what we can say? We can say dp of I comma j is going to be minimum, right? Minimum of what? Mat dot minimum of either you can delete from the row, means either you can delete a character from s1 or you can delete a character from s2. Let's say you're going to delete a character from s2. So you're going to delete a character from s2, then you have to write dp of I and j minus 1, plus you have to take the ASCII value of that particular s2 character. So you can say char s2 dot char code add, right? So once this is done, then what you're going to do? You're going to say j minus 1, right? Either you can delete a character from s1. So for that you can say dp of I minus 1 and j, plus you have to take ASCII value. So you can say s1 dot char code add, and here you can pass nothing but I minus 1, right? Once this is done, then what you're going to do? You're going to come out from this for loop, and you can return dp of nm, right? And after that you can test it by running this code. Let's see. It should pass. It should pass. Let's see. You can see, guys, for all the test case pass. So let's try to submit this code. Finally, it could pass, right? So we have seen the implementation with JavaScript as well, and you can see it also get accepted, right? So guys, we have done the implementation with Python, C++, Java, and JavaScript. I hope you understood all the implementation part. And guys, if you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.